Alright, so this will be the last thing we do with logarithms. We've expanded them, we've combined them, condensed them rather, we've graphed them. Now this is kind of the last thing that we would do with word problems to solve them. So you can see it kind of looks like a lot. These are two different problems. So what's happening is I'm going to pretend that we are starting with $10,000. Now according to this formula, again, the variables don't matter, so I just plugged in the numbers. We should know what everything represents. Start with $10,000. We want to end with $20,000, so we're doubling our money. We have put this money into an account that we get the interest once a year, and we're getting 5%. Now the question that comes up is, how long should the money be in this account until we've reached our $20,000 mark? So what I'm going to do is I'm going to start to isolate this base here. Now by doing the dividing by 10,000, what I've gotten is 2 equals 1.05 to the power of t. So now I have an exponential equation. I have 2 to the first power equals 1.05 to the t power. So this is exactly what we had done where we wanted to take the logarithm of both sides in order to use that property to bring the exponent down. A little side note, if it's ever base e, we want to use the natural log, which is log base e, or ln. If we have any other number, like 1.05, we're going to use the common log, which is log base 10, or just log. So by taking the log of both sides, I can bring down the t. And again, log is not a number, it means we're taking a process. So log of 1.05 is all one term. That's being multiplied by t. So therefore I can divide by whatever the log of 1.05 is. And with my calculator, I'm going to do log 2 divided by log 1.05, and I get 14.21. So that means that if I invest $10,000 at a 5% interest rate that I get once a year, and I want to double that money, I need to wait over 14 years to get that outcome. Same situation, but now I'm going to do base E. Base E means that it's compounded continuously. And now notice that I have an unknown for the R, but I do know that I have 10 years. So again, I have $10,000, I want $20,000, and I only want to wait 10 years. I don't want to wait 14 years. So what interest rate should I be looking for in order to make this happen? So same process, I'm going to divide by 10,000, I get 2. And now I have e to the power of r10. So here's another exponential equation. 2 to the first power is equal to e to the 10r. So I'm going to take the log of both sides. Since it's base e, I'm going to take the natural log. And then using our property, I can bring this exponent down. I just wrote it as 10r because I like having the coefficients in front of the variables. And then I remembered that ln e is the natural log of base e of e, which is 1. So I can replace ln e with 1, and I simply have 10r equals natural log of 2, divide by 10, plug into the calculator, I get 0.069. So that means that if I wanted to double my $10,000 in 10 years, I would need to find an interest rate that was at least 6.9%. So here are 2 more problems to try out. The first one is like the first example. You have $5,000. You're investing it at 0.8% interest compounded quarterly. How long will it take to have $7,500? And the other one is you want to invest $3,500 continuously for 5 years. What interest rate should we look for if we want to have $4,700? Good luck.